Hello students, so this is Vikas Agarwal and we are here to discuss KVPY essay paper of year 2020, and right now we are discussing physics section part 2. So let's get on with the next question. Now this question says that a wide cylindrical massless plastic container of height 9 centimeter has 40 coins, identical coins inside it. Now the significance of using a coin here is that we can consider coins to be entities that have negligible volume. Okay, and with these 40 coins it is found to be floating with 3 centimeter inside the water. So if the coins occupy this negligible volume, okay, so what I can say right now is that the weight of 40 coins, let's put it as 40 into m into g, where m is the mass of one coin, so 40 mg will be equal to the buoyant force, and the buoyant force can be written as density of liquid into area of cross section into the height submerged, which is equal to 3 centimeter, okay, into g. So that will form equation number 1 for me. Now the question says that we start putting more such coin on its lid. So we start depositing coin here, okay. Now we have mass at two places. 40 m mass was present here, some additional mass was put here, we put a total of n coins, so n into m, this much mass was put here. As a result, of course, the submerged part will become more than 3. Okay. And the question also says that the equilibrium changes from stable to unstable. Now, what is the meaning of this condition? The meaning of this condition is that the center of mass of this container plus the coins, the center of mass of this entity coincides with the center of buoyancy, that is the center of mass of the submerged portion. So we are calling it as equation 1. Let me try to make the next figure. So in the next figure what we are suggesting is that we have a container that possesses mass here and that possesses mass here. Okay, let's say it is submerged by to a height h. Okay, now if it is submerged to a height h, then the center of buoyancy would lie here, which would be h by 2, and this is same as the center of mass. Okay, so this height, let me call this height as y for now. Okay, so 40 m mass is present here, n m mass is present here, so I can treat this as a two particle system because the as far as the y coordinate goes, the entire mass is concentrated at only two locations. Okay, so I can write y coordinate like this distance as, I can write it as nm divided by total mass, which is nm plus 40 m into this entire distance, which is 9 centimeter. So this will become 9m upon n plus 40, and this is uh, equal to h by 2. Okay, this is equal to h by 2, or we can say that h is equals to 2 times of y. So that's 18n divided by n plus 40. So we have expressed the submerged portion in terms of n. And next what we can say that the buoyant force corresponding to this submerged portion will be equal to the weight of the all the coins. So we will write this equation. We will write rho A H G is equals to 40 plus N into M into G. So this will become my second equation. So using equation number 1 and using equation number 2, we should be able to get the value of N. Equation 2 can be modified as rho Ag into H. H was 18N divided by N plus 40. Let me just go back and have a look whether I've written the correct value or not. Yeah. Okay, now this should be equal to 40 plus N into mg. This is second equation. Equation number 1 was rho Ag into 3 is equals to 40 mg. So let's divide equation number 2 by equation number 1. When we do so, rho Ag gets cancelled, mg gets cancelled, and this 3 also gets cancelled. So we are left with 6n divided by n plus 40. This is equals to 40 plus n divided by 40, which can be written as 240n is equals to n plus 40 whole square. So that would be n square plus 1600 plus 80n. So ultimately we are left with n square minus 160n plus 1600 is equals to 0. On solving this, we will get two values of n. Okay, one would be approximately 11 and the other would be close to 150. I solved this equation earlier, so I remember the answer. So it will be around 11 and 150. Now, here some of you may have this query that out of the given options, if we have to select, then this is the best option. But what about 150? Why are we ruling it out? Or can that also be one of the correct options? So guys, the answer is no. 150 cannot be the correct answer because understand this. This total height is 9 centimeter, and when we used 40 coins, we were able to submerge 3 centimeter of it. So if I add another 40 coins, 6 centimeter will go under the water. If I add another 40 coins, that means if I add a total of 80 more coins, then this object will completely be submerged under the water. So before this happens, we will get to the stage where the stable equilibrium changes into the unstable one. So we are looking for the smaller value of n that can satisfy this equation. So 11 would be the correct, like any value which is close to 10 would be the correct answer. Out of the given option, we can pick 10 as the correct answer. So guys, I hope you liked the solution. I hope you understood the solution. That's more important. And thank you for watching. Stay tuned for the next question.